Every climate story begins with something we cannot see: carbon dioxide, floating silently in the air. It comes from power plants, factories, vehicles, heating, and the way modern life uses energy. Once released, CO2 does not simply disappear. It can stay in the atmosphere for a long time, traps extra heat, making the planet warmer over time. So scientists asked a powerful question: can we take CO2 and lock it away safely? Not just hiding it, not just storing it, but turning it into stone. This is carbon locking, a way to trap carbon in solid minerals. The key is basalt, a dark volcanic rock full of minerals that can react with CO2. Basalt may look lifeless, but chemically it can become part of the solution. Inside rocks like basalt are elements such as calcium, magnesium, and iron. When CO2, water, and these minerals meet, a chemical reaction can begin. The CO2 changes form. It becomes part of a solid mineral, like nature making stone. Nature already does this, but usually over very long timescales. The challenge is to speed up this natural process without making it unsafe. First, CO2 must be captured, either from industrial sources or directly from the air. Some machines can even pull CO2 from open air, like a giant scientific filter. After capture, the CO2 must be moved safely to the right kind of rock. In some systems, CO2 is dissolved into water before it goes underground. Once dissolved, the CO2 can travel with water into deep volcanic rock. The injection well becomes the doorway between human technology and the deep earth. Down it goes, past soil, stone, and pressure, into the reactive rock below. Once inside basalt, the liquid spreads through cracks smaller than your finger. The water helps unlock minerals from the rock, preparing them to meet CO2. Then the chemistry changes. Carbon begins to move from gas into solid stone. Little by little, the captured carbon becomes mineral, stable and solid. This is the breakthrough. The CO2 is no longer moving freely. It is locked into stone. The underground space changes from a pathway for carbon into a place that stores it. Storing carbon as mineral is powerful because solid rock is difficult to release. But scientists do not simply inject and walk away. They monitor the underground system. Water chemistry, rock samples, and sensors help show whether mineralization is happening. In the rock, scientists look for evidence that carbon has become mineral. Places with volcanic rocks like Iceland have become important testing grounds. Some projects use geothermal energy and volcanic rock together in one system. This means CO2 can be captured from the air and stored deep below as mineral. But there is a challenge. The world releases enormous amounts of CO2 every year. Carbon locking needs the right rocks, the right water, and the right engineering. Some methods need water to dissolve and transport CO2 underground. So this is not magic. It needs energy, planning, monitoring, and careful site selection. Good carbon storage must be measured, verified, and watched over time. Carbon locking may also happen in crushed rocks and some mining wastes. Some technologies try to lock CO2 into building materials and industrial products. The goal is the same: move carbon from the air into stable, solid form. In a way, this idea copies Earth's own long-term carbon storage system. The question is whether humans can speed up nature without breaking its balance. Carbon locking is not the only solution, but it may become an important one. We still need to cut emissions first. Storing carbon cannot replace prevention, but for some industries, carbon capture and storage may help deal with difficult emissions. In the future, storage sites may become carefully monitored climate infrastructure. Communities must understand what is happening beneath their land and water. Trust comes from open science, clear data, and honest communication. The molecule that once floated in the air now becomes part of the earth. This is the promise of carbon locking, turning a climate problem into a stable mineral. The science is still growing, but the idea is powerful. Work with geology, not against it. If we can capture carbon and lock it safely into stone, the future may become a little more stable.